Hey guys, welcome back. Hope you enjoyed your time off. We're going to start this next quarter a little bit easy. We're going to talk about polynomials, but before we get to the all nitty-gritty aspects of polynomials, especially dividing them, we're going to just talk about some of the definition sort of parts of things and identification parts of it, so that we know what we're talking about, all this vocabulary essentially throughout our polynomials as we go through and learn how to do all sorts of math with them. All right. I apologize. This video is a bit scrambled. It's my first day back from break as well, so there might be some mistakes or some things happening. We'll find out as we go. I got the PowerPoint set up, but I didn't really practice this. So here's some words in terms of some definitions that you might want to be familiar with. Definitely might see these definitions pop up on a quiz. Obviously, there's no definitions yet, but there will be defined throughout the PowerPoint. All right, like some are here. A monomial. Let me kind of give you an example of what a monomial is. A monomial is a number or a product of numbers and variables with a whole number exponents. So some examples of a monomial would be like 2x. Because it's a number or a product of numbers, in this case, and variables. Product of numbers and variables. 6 is a monomial because it is just a simple number. Let's see, 3x squared is a monomial. Basically, it kind of means one term in a sense. A monomial is basically like one term. It could be something kind of weird looking, like 3xy squared, where we actually have two variables, but that's okay as well. But it's still considered to be one term. So those are monomials. A polynomial is a kind of combination of these monomials. So 2x plus 6, that's a polynomial. It's a sum or difference. Basically, we're adding together monomials. So we said 2x was a monomial. We said 6 was a monomial. But when we put them together, 2x plus 6, that's a polynomial. Poly means more. So monomial means 1. Polynomial means more than 1. So 2x plus 6 is a polynomial. 3x squared plus 2x minus 1 is a polynomial. Basically more than one term. And a weird looking one might be like 3xy squared plus 6x squared y. These are still two terms, but it's a polynomial because there are two terms. Alright, polynomials have no variables in the denominators or exponents, no roots or absolute values. Basically nothing goofy looking, like 1 over x, or like maybe something like 2 to the x power, or what else does it say? Absolute values, so of variables like absolute value of y or something. Those would not be considered monomials or polynomials. Right? You can see here's some examples down there as kind of writing, but you can see those as well. So that's just what a monomial is. That's what a polynomial is. All right. The degree of a monomial. Now this is very interesting. Make sure I kind of emphasize this. Can I erase that, please? Thank you. The degree of a monomial is the sum of the exponents of the variables. Now, typically, we'll deal with just terms that only have one type of variable in it. Something like 3x to the third, or 2x squared, or 5x to the fourth. These terms only have one variable, and those variables only have an exponent. So those are typically what we'll talk about. Now, the degree of this would be 3 because the exponent's 3. The degree here is 2 because the exponent's 2. The degree here is 4 because the exponent's 4. So the degree of the monomial is basically its exponent. But this talks about something a little bit more elaborate, and that's, sum of exponents. So what does that mean? Well, because, 4 is the only exponent in this term, let's say, obviously the sum of 4 is just 4. It's the only one. So when you add itself, it's just itself. But let's talk about something like 3x y to the third. Or let's do 3x squared y to the third. Right? That is still considered a monomial. We've already mentioned this. But it's got more than one exponent. So what's its degree? Is it degree 2? Is it degree 3? No, it's actually a degree of 5. because remember the degree is the sum of the exponents. So this is all one term. This one term has two exponents. So we add the exponents together, we get the degree of that monomial, of that term. So another one, say 4a to the 5th, b, c to the 7th. That is considered one term because, there's no plus or minus, it's just kind of all grouped together. But the degree would be a 5 plus a 1 plus a 7, which would make, 13? So that would be a degree of 13. All right. But typically, we're going to see most of the time something like this, where it's just one term with one exponent. So the degree is going to be pretty obvious. But if you have a really goofy looking term that's got multiple parts, multiple variables, and multiple exponents, then you add the exponents to get its degree. All right, so let's identify a degree. Let's kind of practice here. Now this is just one single term with one single variable and exponent. That's a 6th degree, right? Because its exponent is a 6, that's how we kind of identify it. Since the exponent's by itself, it's pretty easy to identify what that degree is. All right, now this is 5.6. This is interesting. We haven't mentioned that yet. There are no exponents on any variables. It is important that we remember, by the way, that we're talking about when I say degree. Does it outline it here? Yeah, exponents of the variables, not a number. So let's say it was 5.6 squared. The degree wouldn't be 2 because the squared is not on a variable. It's not there anyway, but it's still kind of important to point that out. It's not 1. Technically, the exponent is 1 here, but it's not a degree of 1 because that exponent is not on a variable. Well, you're probably saying, well, 5.6, there are no variables here, right? There's no x, there's no y, there's no variable. Correct, which means it's a degree 0. Right? There is no exponent on any variables because there is no variables, so that's a degree of 0. All right. C, 8x, y to the 3rd. Notice the variables on the exponents on the variables. So x has a power of 1, y has a power of 3. Since there's more than 1 here, we add those together. That's going to be a degree of 4. Call that 4th degree. And then this one, again, it's all bunched together. We're going to add the exponents on the variables. The variable a has a 2, b has a 1, and c has a 3. So it's going to make this a 6th degree. Because if you add those exponents up, 2 plus 1 plus 3 is 6. So it's going to be a 6th degree term. All right, now, degree of polynomial. This is where things get kind of mixed up for you guys. It's not hard, but you just tend to mix this up. It's given by the term with the greatest degree. A lot of times people like to add all the exponents throughout an entire polynomial when all they have to really do is just look at the biggest degree term. They only have to look at one term, not all of them. All right, I'll mention what I mean by that in an example later on. All right, well let's go ahead and let's give you one. Why not? A polynomial. Let's make a polynomial like 5x to the 4th plus 3x to the 3rd minus 7. Let's just say that. Something, okay? That's a polynomial, and I want the degree of this polynomial. Now, it's a little bit different than monomial because a monomial is when you added the exponents together. But here, I just want given by the term with the greatest degree. So there are 3 terms here. There's 1, there's 2, there's 3. Identify the degree of each term, and whichever one's the highest is the one we're going to take as our answer. So this 5x to the 4th, that's a degree 4. 3x to the 3rd, that's a degree of 3. And that's a 7, doesn't have a variable, doesn't have an exponent, so it's a degree of 0. So the first term is degree 4, the second term is degree 3, and the last term is degree 0. So we just want the biggest one. So the biggest one is 4, which means this whole polynomial, that's a 4th degree polynomial. All right? We don't have to add them all up. We're just taking the biggest term. Okay? Now, as the terms are exotic, let's say, we have 7a to the 3rd, b to the 2nd, plus 3a to the 5th, b to the 6th, minus 8 a to the 4th b. You know, we've got some exotic things going on. We got multiple variables with exponents. But I'm not going to add them all up. I just want, let's find the degree of each term. And whatever's the biggest degree is what we're going to say for the whole thing. So the first term has a degree of 5. Because the 3 exponent and the 2 exponent add them up, it's 5. The second term has a degree 11, because 5 plus 6 is 11. And the last term has a degree of 5, because a to the 4th and b to the 1st, 4 plus 1 is 5. So what's the biggest degree? The biggest degree is 11. So in total, this whole polynomial is an 11th degree polynomial. Okay? We're not going to add the degrees of all terms together. We're just going to find the term of the biggest, and that's going to be the degree for the whole polynomial. It's basically kind of like the leader of the polynomial, if you will. Right? So let's talk about what some of this other stuff says. Standard form, terms written in descending order by degree. The degree of the first term in the case of degree of the polynomial, leading coefficient is the coefficient of the first term. So in standard form, it's basically an easier way to identify these things. We can still identify the degree of the polynomial and the leading coefficient, even if it's not in standard form. But having it in standard form makes it really easy to figure out what the degree of the polynomial is and what the leading coefficient is. So, what do I mean by standard form? Let's say we have a quadratic. That's very typical for us to have. 3x minus 7 plus 2x squared. That's a quadratic, but it doesn't look like a quadratic because it's not in the right order. It's in a really goofy order. To write it in standard form, we write it basically, again, from the biggest degree to the smallest, descending order by degree. So, this first term, that's a degree of 1, because x to the first power. The second term, that 7, has no variable, has no exponent, that's a degree of 0. And this last term has a degree of 2, because its exponent is 2. So if I want to rearrange, because that's all I'm doing here is rearranging, in the standard form, I'm going to write from the biggest degree term, which is the last one, down to the smallest degree term. So it should be 2x squared as the biggest degree, plus 3x, because that's the next biggest degree, and then minus 7 at the end, because that's the smallest degree. So that's standard form, writing it from the biggest degree to the lowest. It's pretty easy to do because you're kind of just listing the exponents from the biggest exponent down to the smallest exponent. So this kind of goes 2, 1, 0. All right. Another one that we'll see kind of a little bit of is, let's say you have, something like fourth degree. Let's say I have 5x to the fourth. Let's not start with that. Let's say I've got 3x squared minus 2 minus 5x to the fourth minus 7x to the third plus 2x. So there's my polynomial. It's not written in standard form, however, because all these degrees are kind of all over the place. But if I want to put it in standard form, I want to go from the biggest degree to the smallest. So let's look at all 5 terms here and which one has the biggest degree. The 5x to the fourth, but keep in mind it's a negative 5x to the fourth. So that negative, since it is a minus 5, that minus goes with that 5. We're going to need to keep that in mind. So it's a negative 5x to the fourth. That's the biggest degree. The next biggest one would be the minus 7x to the third. The next biggest one would be the 3x squared. It's positive, so it'll be plus 3x squared. The next biggest would be the plus 2x. And then the last would be minus 2. So it's the same polynomial, but I just rearranged the terms in standard form from the biggest degree to the smallest. And again, if you don't see it, biggest degree 4, 3, 2, 1, and then 0. Now let's also talk about the leading coefficient. The leading coefficient is the coefficient of the first term. This is when it's written in standard form. So when it's written in standard form, the coefficient is the coefficient of the first term. The first term is 5x to the fourth. The coefficient, or negative 5x to the fourth, is negative 5. So negative 5 is the leading coefficient. Again, coefficients are just the numbers in front of the terms in front of the variables with exponents. So, negative 7 is a coefficient, positive 3 is a coefficient, positive 2 is a coefficient, and negative 2 you kind of consider a coefficient as well, although technically we'll kind of note it as a constant. Those are all quote-unquote coefficients. The leading coefficient, as you suggest by the name, is the one out front. So it's the very first one, but the catch is it's only the very first one when it's written in standard form. Technically, even if it's not written in standard form, negative 5 is still considered our leading coefficient. So that's kind of silly, even when it's not written in standard form. So, but it's technically still the same thing. If it's written in this way, it's not like 3 magically becomes a leading coefficient. It's not. It's just deceptively out front because it's not in the right order. So it's very important. We put it in the correct order, then we can identify the leading coefficient because, again, leading is right out in front. It's going to be pretty easy to identify. All right. So these are things we might kind of already be familiar with. Polynomial with one term is a monomial. So we've already kind of been over what a monomial is. Let's say 3x squared is a monomial. A polynomial with two terms is a binomial. So let's say I have 5x plus 7. I'm sorry, 3. I don't know why I said 7. I was thinking 7, but I wrote 3. That's a binomial because there are two terms, right? And a trinomial is something with three terms. So if you have x squared plus 5x plus 6, that's a trinomial because there are three terms. Anything with 4 terms or more, we just call regular polynomial. We don't give them any special names. These are all polynomials, by the way, but they have a more specific name to go with them. One term we can just call monomial, 2 terms binomial, 3 a trinomial. And anything, like I said, with 4 or more, we just call a regular polynomial. Alright, I'll let you kind of look at that. These are names as well to their degree. So constant, degree of nothing. You can see an example of it. It's just a basic number. Linear, first degree. Right? Basically, something in like mx plus b form is very typical for this. X to the fourth, 5x plus 2. Stuff like that. Just even if it's just 6x, that's still a linear. It doesn't have the plus 2 or the minus 4, but it still has the x to the first power. It's still a degree of 1, and we would call that linear. Quadratic has a degree of 2, cubic has a degree of 3. It doesn't have to have all these terms in it, but it just means that the highest degree is a third degree, or a second degree, or a fourth degree. That's all it needs to be a cubic, a quartic, a quadratic, whatever it is in terms of what degree it is. Alright, rewrite each polynomial in standard form. So you can give me the answer. I don't want them to give me the answer. Okay, cool. And then let's identify all these different things. So, it should be pretty easy. The standard form means the biggest degree to the smallest. So for A, we're going to write these 3 terms. The biggest degree is going to be this negative 5x squared. The next biggest will be this plus 4x. And then the very smallest will be the plus 3. Okay. So there's my degree in standard form. The leading coefficient is the coefficient up the very front when it's in standard form. So the leading coefficient is negative 5. Degree, since the highest degree term is a degree of 2, then the degree of the polynomial is a degree of 2. Terms, well, there are 3 terms here. You can count them. 1, 2, 3. We can also, remember, call that a trinomial. All right? Oh, I guess that's what it means by name. So, name trinomial. Technically, you could call this, I guess, maybe if you want to be more specific, because this you would also call a quadratic. The full name would be a quadratic trinomial. I know it's written terrible, but we just got off the break. I don't really feel like taking my time. All right. So B, let's write this from the biggest degree term to the smallest degree term. The biggest degree term is 8x to the fourth. The next biggest degree term is 3x squared. And then the smallest degree term, or the last one, is this minus 4. So there it is. The leading coefficient is 8, because 8's the coefficient at the very front. It's not 8x to the fourth, by the way. The coefficient is just the number. Okay, so it's just an 8. The degree, well, the highest degree, as we know from this first term, that's a degree of 4. So here we have a 4th degree polynomial. Terms, there are 3 terms altogether. And so a name, we would call this, I guess, a 4th degree trinomial. You thought we just got off a break because I can't spell things. 4th degree trinomial. Alright. Could try this one as well. I'm going to kind of, I guess, skip past it. We can do it real quick. I probably won't explain it, but you can pause the video and see if you can get it right. Alright. Coefficient negative 2, 3, 2, also term. Term 3, this should be a quad. I know this video is getting kind of long and I don't want to do that, so I'm going to kind of make this go by a little bit quicker. Now, the leading coefficient here is 1, by the way. Since there is no number, it is still technically a number. There's a 1 there. It's a 1x to the 3rd. Degree, well, it's cubic. We just said that. It's the 3rd degree. We call that cubic. Terms, there are 4 of them. So this would be a cubic polynomial. Alright. I think that's going to cover it. There's this little exit slip homework that I gave. I know that video kind of ran a little bit long, but I want to be very thorough, very complete with you guys. This is pretty easy stuff. It's just kind of a study sort of thing. Go home, review what a trinomial is, review what putting in standard form is, all those different things, those definitions. Those definitions will be on a quiz. So it's more or less just study than really practice work. There's not a whole lot of problem solving here. You just kind of have to know what things are what things. So I'll leave you at that. I'll see you in another video in the future. Welcome back from break. And what a good way to get started. All right, see you later.